Okay, this is Chapter 7, Jet Aircraft Applied Performance. This is going to be a short lecture. The first thing I want to point out is on page 97 and figure 7.1, the effect of weight change on induced drag. So you can see induced drags is plotted on the left, and then on the y-axis and on the x-axis is airspeed, and you can see how the induced drag is different between the various weights, 8,000 pounds and 12,000 pounds. So drag is important in jet aircraft, probably a little bit more important than it is in propeller-driven aircraft. In figure 7.3, you can see the effect configuration changes when we have gear down or gear clean on parasite drag. This is figure 7.3. And this should be pretty obvious to you that as the gear's down, you're going to have higher parasite drag than you are in the clean configuration, especially at the higher airspeeds. So gear down at 400 knots is a lot of drag. But you're normally not going to have gear down there, so it's not in the landing configuration. You're going to be a slower airspeed, somewhere between 100 and 200. So it's going to be somewhere, if this was still T-38, I think that's what we're looking at. I think the touchdown speed somewhere around 150 or so, 130. So it's going to be roughly 600-700 pounds of parasite drag based on the gear down configuration. Just make sure you can read that chart and that makes sense to you. One equation to look at, and this is based off of L over D, and how weight changes is D2 divided by D1 is equal to W2 over W1, and this is for under 1G flight, and lift is equal to weight. Figure 7.5, this is effects of altitude on the thrust required and thrust available curves. So on the left hand side you'll have fuel flow and thrust required and available in 1,000 pounds, and then velocity and true airspeed. So the above curves show that the minimum thrust required is 830 pounds for both altitudes. And so this means that the L over D max is not changed by altitude. And we can see that 830 pounds there. It's right above the 0.5 line. So the true airspeed for minimum drag does not change, as shown in figure in equation 7.2. And if the inlet velocity at sea level and the density ratio is equal to 1.0, we can calculate the exit velocity, which is equal to V2, which is equal to the inlet velocity divided by the density ratio. If you look at page 102, you'll see some definitions. Go ahead and take a look at these. You should read page 102 and page 103. Figure 7.6 shows you the effective weight change on specific ranges. So take a look at that. Clean configuration, sea level standard day, L over D max, where that occurs. And that's it. So there's only two equations. You'll see those on page 104 for chapter 7. So really this is just having the concept of how weight and altitude changes thrust required and thrust available, and how drag has a changes on thrust as well. Okay, so pretty straightforward in chapter 7. If you have any questions on any of this, give me a shout and be happy to help you. Again, we're just trying to get some basic understanding of jet aircraft performance here, so you have some basic understanding of what occurs. Thank you for your time.